Hey everyone, buckle up, because today we're diving headfirst into this wild world where SQL databases transform into full-fledged web application platforms.
Yeah, you heard that right.
I know, crazy right. We're talking TSQL.APP, folks.
TSQL.APP.
A platform that lets you build interactive web apps primarily using T-SQL. Can you believe that?
It's mind-blowing. Really flips the script on how we think about good old Microsoft SQL Server.
I was looking through the research, and I gotta say,
Yeah,
it's like stepping into an alternate reality.
I know what you mean.
Are we really going to build an entire web app just using SQL?
It's wild.
But the more I dug into it, the more it actually started to make sense.
Right.
So how does this TSQL.app magic actually work?
Well, at its core,
Yeah.
the platform uses stored procedures to dynamically generate the front-end components of your web app.
Really?
Yeah, we're
Yeah.
talking HTML, CSS, even JavaScript, all being created from your T-SQL code.
Whoa, so your database is basically speaking fluent web development now.
It's exactly like that.
So instead of writing separate code for the front end, you're essentially defining the entire structure and behavior of your application right inside SQL Server.
You got it.
Okay, so how does that even work?
Well, it gets really interesting here. There's this built-in event handling system that uses SQL variables as triggers for dynamic UI updates.
Okay, so paint me a picture.
All right, so picture this. A user clicks a button on a web page, and that click triggers a T-SQL script to execute,
Okay.
instantly updating the interface in real time.
Hold on. Are we saying there's like a live two-way communication happening between the user's browser and the SQL Server database?
You got it. And to illustrate this, the documentation provides a really cool example of a real-time clock built using TSQL.APP. They use a stored procedure called SPAPI Modal Refresh to constantly update the clock's display without requiring a full page reload.
Interesting.
It's a really clever way to handle state management and ensure seamless interaction between the client and the server.
Okay, my brain is officially doing backflips trying to process all of this.
I know, it's a lot.
But let's move from theory to practice here for a second.
Sure.
What kind of UI components can we actually build with TSQL.app?
Right.
Surely we're not just limited to clocks.
Oh, absolutely not. It's way more versatile than that. TSQL.app has a bunch of built-in UI components like grids for displaying data, forms for user input, modal pop-up windows, and so on. And remember, all of these are controlled and manipulated through your T-SQL code.
I'm particularly intrigued by this card system they describe in the docs.
Yeah, the card.
It's like a way to visually represent your data and interact with it directly.
You nailed it. Imagine transforming your database tables and views into these interactive UI elements, each with built-in functionality for creating, reading, updating, and deleting data.
Oh, right. The classic CRUD Operations.
Exactly. And here's where the flexibility of TSQL.app really shines.
Okay, fat.
You can create multiple card views for a single database table.
Okay.
Each presenting a different aspect of the data.
So let's say I have a database table called company.
Yeah, company.
I could have one card view focused on customer interactions.
Right.
Another for supplier details. And maybe even one specifically for financial information.
Okay.
All drawn from that same company table.
Precisely.
It's like having different lenses to view and manage your data.
It is.
Making the whole system incredibly dynamic.
Absolutely.
This is all starting to click, but I'm still a bit fuzzy on how these cards actually work behind the scenes.
Sure.
The documentation mentions something called meta tables.
Yeah, the meta table.
What's their role in all of this?
So think of meta tables as the blueprints for your cards.
Blueprints?
Like configuration files that tell the system how each card should look, behave, and who has access to it.
Okay.
There are specific meta tables like AppAcard fields, and AppAcard actions. They define the structure, the data fields displayed, and even the actions users can perform on each card.
Wow, that's a pretty granular level of control. It sounds like developers can really fine-tune the user experience and tailor it to their specific application needs.
For sure.
And the best part is that all of this configuration happens through T-SQL scripts.
Right, in the database.
It really blurs the lines between front-end and back-end development.
Oh.
There's a lot to take in.
Yeah.
We've gone from building a simple clock to customizing interactive data cards all through T-SQL.
Yeah, it's a lot.
Incredibly powerful. But before we get too deep into the technical weeds, what are your initial thoughts on all this? Anything about TSQL.APP that particularly stands out to you?
Honestly, it's the potential for rapid development.
Okay, rapid development.
That has me really excited.
Oh, yeah.
If you can truly build a fully functional web application using just T-SQL and a few configuration tables,
Yeah.
that's a game changer, especially for database-centric applications.
Yeah, I agree. Being able to leverage your existing SQL Server knowledge and infrastructure is a huge advantage.
Right.
Could significantly reduce the learning curve and speed up development time.
For sure.
But before we get ahead of ourselves, let's not forget about two critical aspects of any web application.
Yeah, what's that?
Security and state management.
Oh, right. Those are big ones.
How does TSQL.APP handle these crucial elements?
Great question.
Let's dive into that next. After all, we don't want just anyone tinkering with our precious data, right?
Would you not? So when it comes to security, TSQL.APP doesn't mess around.
Oh, really?
It's got this robust system called role-based access control, or RBAC for short.
RBAC, okay.
Basically, it's like setting up different levels of access for your app.
Gotcha.
You define roles
Right.
like admin, editor, or viewer.
Okay, so like...
And then you assign specific permissions to each role.
So it's like a digital bouncer at the door of your application, checking everyone's ID to see who's allowed in.
Yeah.
And what they're allowed to do once they're inside.
Exactly. And the system uses those security tables we talked about earlier.
Oh, right, right.
Like appealser to store user information, domainizer claim to link permissions to specific users.
Okay.
And AppToken claim rules to determine access based on those claims.
Gotcha, gotcha.
It's all about keeping your data safe and sound.
Okay, that makes sense. But from a developer's perspective, how do you actually implement these security checks?
Right.
Do you have to write complex T-SQL queries every time you want to restrict access to something?
Thankfully, no. TSQL.APP provides some handy functions to make life easier.
That's always good.
One of them is called hasRole.
hasRole.
And it's super intuitive.
Yeah.
You can use it to quickly check if the current user belongs to a specific role.
So if I'm building, let's say, a dashboard with sensitive financial data.
Yeah, sensitive financial data.
I could wrap that section of code in a conditional statement.
Right.
Like saying, if the user has the financial analyst role, show them this data. Otherwise, keep it hidden.
You got it.
Okay, cool.
And you can get even more granular with the permissions.
Oh, wow.
The research mentions using claims to control access to specific features or even individual fields.
Oh, wow.
Within a card.
Okay, so it's like having fine-grained control over who sees what.
Exactly.
Right down to the smallest detail.
It is, yeah.
Think of it like this.
Yeah.
You wouldn't give everyone the keys to the vault.
Oh,
right?
exactly.
Great analogy.
Thanks.
But speaking of data, how does TSQL.APP handle all the information that's constantly flowing through the application?
Right.
We're talking about user input, session data, all the other stuff that needs to be tracked and managed as users interact with the app.
So that's where the state persistence mechanism comes in.
State persistence mechanism.
It's actually quite ingenious.
Okay.
How TSENL.APP uses T-SQL variables and JSON data structures.
Wait, hold up, JSON.
JSON, yeah.
In SQL Server. I always thought of JSON as more of a web development thing.
It is, and that's exactly what makes this platform so fascinating.
Okay, yeah, I see that.
It's all about bridging the gap between SQL Server and web applications.
Right.
By leveraging JSON, TSQL.APP can handle more complex data structures.
I see.
And easily pass information between different parts of the application.
So let's say a user is filling out a form.
Yeah, filling out a form.
On a TSQL.APP application.
Yeah.
That data could be captured, packaged into a JSON object.
A neat little JSON object.
And then stored within a T-SQL variable. And then later, we could use that same JSON data to, say, pre-populate another form or trigger a specific action.
You got it. It's all about making the data flow smoothly and efficiently.
Yeah, keeping things moving.
And the documentation stresses the importance of variable synchronization.
Variable synchronization.
Which basically means making sure that the data on the user's side
the client.
And the data on the server are always in sync.
Okay, got to keep them talking.
Exactly. And they use a stored procedure called SPAPA modal value to manage the synchronization process.
Okay, this all sounds very intricate, but also very clever.
It's pretty cool.
It's like they've created this whole system where data can seamlessly flow between the front end and back end.
Yeah, it's neat.
All within SQL Server. But I have to ask, are there any potential pitfalls?
Oh, yeah, good point.
developers should be aware of when working with this state management system? It seems like there could be a lot of moving parts.
Yeah, that's a great question. And you're right.
Yeah.
Things can get complex.
Right.
One of the key things to consider is error handling.
Error handling, right?
Imagine a scenario where a user accidentally enters invalid data into a form.
Okay.
Or there's a network hiccup.
Right.
During the data synchronization process.
That makes sense.
Developers need to build robust error handling mechanisms to ensure the application doesn't, crash and burn.
Right, because a well-handled error is like a gentle nudge back on track.
Yes.
But an unhandled error can be like a sudden derailment.
Yeah.
And in a system where the line between front end and back end is blurred like this.
Yeah, it gets even more and more.
Error handling becomes even more critical.
Absolutely.
Yeah.
It's not just about catching errors.
Right.
It's about gracefully recovering from them. Providing helpful feedback to the user. And ensuring the application remains stable and reliable.
Right, stable and reliable. That's what we want.
Yeah. While we've been diving deep into the core mechanics of TSQL.APP.
Yeah, the core mechanics.
I'm curious to explore some of its more advanced capabilities.
Okay, advanced capabilities, I like it.
Can this platform do more?
Yeah.
Than just basic CRUD operations and simple UI elements? The research hinted at some pretty interesting features.
Oh, I love getting into the cool cutting-edge stuff. You mentioned custom CSS styling, keyboard shortcuts, and even integration with external APIs.
Exactly.
It's starting to sound like a full-fledged web development framework, but all within SQL Server.
Right. And what's really neat is that these advanced features are still rooted in the simplicity of T-SQL.
Oh, okay, cool.
Like take custom CSS styling, for example.
Custom CSS styling.
You can inject your own CSS styles directly through stored procedures.
Oh, really?
Giving you fine-grained control over the look and feel of your application.
So if I want to tweak the design, add some visual flair, or even make the app match my company's branding, I can do all that.
You can.
Within my T-SQL code.
It's all about empowering developers.
Oh, that's awesome.
To use their existing SQL Server skills to build sophisticated and visually appealing web applications.
Yeah, very cool. Okay.
And speaking of sophistication, let's talk about the auto refresh functionality.
Auto refresh.
This is where things get really dynamic and a little bit magical.
A little bit magical. All right. I'm intrigued.
Remember that real-time clock example we discussed earlier?
Yeah.
That's just a taste of what you can achieve with TSQL.APP's auto-refresh capabilities.
So we're not just talking about clocks ticking away here.
No, we're not.
What other real-world scenarios can you imagine this auto-refresh feature being used for?
So picture this. Live dashboards.
Okay, live dashboards.
That constantly monitor system metrics, track the progress of complex tasks, or even display time-sensitive data.
Okay, time-sensitive.
Like stock prices or sensor readings.
Oh, okay, gotcha.
It's all about keeping the information flowing.
Right, up to date.
And ensuring the user always has the most up-to-date view.
Makes sense, yeah.
And the beauty of it is that it's all driven by T-SQL. And that clever SPAPA modal refresh stored procedure we talked about earlier.
So instead of constantly bombarding the server with requests for fresh data.
Right.
Or writing complex code on the client side to handle the updates.
Exactly.
I can simply set up an auto-refresh interval within my T-SQL code and let TSQL.APP do all the heavy lifting.
You got it.
That's very cool.
It's all about simplifying development, making things more efficient, and giving developers the tools to create truly dynamic web experiences.
Dynamic web experience.
And the fact that all of this happens within SQL Server is a huge bonus.
Right. But of course, with all this talk about real-time updates and data flowing back and forth, we have to address the elephant in the room.
The elephant? What's that?
Performance.
Oh, right. Performance.
Wouldn't constantly refreshing the data.
Yeah.
Put a strain on the server.
Potentially, yeah.
Especially if you have a lot of users.
Yeah.
Simultaneously accessing the application.
It's definitely a valid concern.
Yeah.
The research emphasizes being mindful of resource usage.
Okay.
And optimizing performance.
Right. Got to be careful with that.
Developers need to carefully consider the refresh intervals.
Avoid generating unnecessary data.
Okay.
And potentially use techniques like partial updates.
Oh, partial updates. Interesting. To minimize the load on the server.
So it's all about striking that delicate balance between keeping the data fresh and up to date.
Yeah, that's right.
While also ensuring the application runs smoothly, even under heavy load.
It is.
It's a classic optimization puzzle.
It is puzzle.
This all sounds incredibly impressive.
It is cool stuff.
But before we get too carried away singing the praises of TSQL.APP, I think it's important to be realistic.
Right.
And talk about potential limitations.
Yeah, good point.
Every technology has its strengths and weaknesses. Right.
They do.
What are some of the potential downsides or drawbacks we should be aware of?
That's a very important question.
Yeah.
While TSQL.APP offers a lot of advantages.
Right. We've seen a lot.
Particularly for those who live and breathe SQL Server, there are some potential limitations.
Okay, limitations, let's dive into that. What are some of the things that might give developers pause when considering TSQL.APP for their next project?
All right, well, first of all, TSQL.APP is pretty tightly bound to Microsoft SQL Server.
Ah, okay, so it's not exactly a one-size-fits-all solution then.
Right. And while T-SQL is a powerful language, especially for working with data, it wasn't really designed with front-end development in mind.
Right. It's not its forte.
Some developers who are used to working with dedicated JavaScript frameworks might find T-SQL a bit limiting when it comes to building complex user interfaces.
Yeah, it's like trying to use a hammer to screw in a light bulb.
Exactly.
It might work in a pinch.
You can get it done.
But there's probably a better tool for the job.
While TSQL.APP offers some UI customization options, it's probably not as flexible or as feature-rich as using a dedicated front-end framework like React or Angular.
Right, so those are still king for UI.
Especially if you're building highly interactive applications with lots of custom UI elements and animations.
So if you're aiming for like a cutting-edge user experience that pushes the boundaries of design, TSQL.APP might not be the ideal choice.
True.
Okay, that makes sense.
It's probably better suited for applications where the user interface is primarily focused on displaying and interacting with data rather than on delivering a super flashy visual experience.
So more function over form then.
Think internal tools, data management dashboards, or even rapid prototyping.
Right, those make sense, yeah.
Another thing to think about is scalability.
Scalability, oh right, we talked about performance optimization.
Exactly.
But can TSQL.APP really handle a massive influx of users or huge data sets? What happens if our application suddenly goes viral?
That's the million-dollar question.
It is, yeah.
And honestly, it would require more in-depth analysis and real-world testing to give you a definitive answer.
Sure, yeah, of course.
The way TSQL.APP is architected, with its reliance on stored procedures and session state management, could potentially pose some scalability challenges.
Okay, so it's not something to be taken lightly.
It's not, no.
So if you're building an application that you expect to handle thousands or even millions of users.
Right, high traffic stuff.
You definitely want to do your due diligence.
Oh, sure.
And make sure TSQL.APP can handle the load before going all in.
It's not to say that the platform can't scale.
Right.
But it's definitely a crucial factor to consider during the plan and architecture phase of your project.
Yeah, don't want to get caught off guard.
Exactly.
It seems like TSQL.APP might not be the ultimate magical solution.
It's not a silver bullet
for every web development challenge out there.
But it does offer a unique and potentially very powerful approach for certain types of applications.
Like what?
Particularly those that are heavily database driven.
Okay.
And where speed of development and tight integration with the database are top priorities.
So for internal tools.
Yes.
Data-centric applications, or even quick prototypes.
Exactly.
Where you need to get something up and running quickly.
Rapid.
TSQL.APP could be a real game changer.
It could be.
For sure.
It allows developers to tap into their existing SQL Server skills.
Leverage that knowledge.
And build web applications quickly and efficiently without having to learn a whole new set of tools and technologies.
That's huge for teams.
And who knows, maybe as the platform continues to evolve, some of these limitations.
Right, the stuff we talked about
might be addressed.
It's always evolving.
In future releases.
Innovation never stops.
Right.
Never stops.
Well, I have to say, this has been an incredible deep dive. We've explored how TSQL.APP transformed SQL Server into a web application platform, delved into its security model and state management, and even touched on some of its advanced capabilities.
We covered a lot of ground. It's been a wild ride.
It has. And we've really only scratched the surface.
Yeah, just a taste.
There's so much more to discover and explore.
So what's the takeaway for you, our listener? Should you drop everything and start building all your web applications with TSQL.APP?
That's ultimately up to you.
It is, yeah.
We've given you a lot to think about.
Food for thought.
Both the exciting possibilities and the potential limitations.
Right. Gotta weigh those.
The key is to weigh these factors carefully. Consider your specific needs and constraints, and then decide if TSQL.APP is the right fit for your project.
Solid advice.
If you're a SQL Server guru who needs to whip up data-centric applications quickly,
yeah, if you live and breathe
the
SQL,
TSQL.APP is definitely worth checking out.
yeah, give it a shot.
You might just fall in love with its unique approach.
Yeah, you might just discover a whole new way to build web applications.
And as always, we encourage you to explore, experiment, and keep learning.
Keep learning, yes.
The world of technology is constantly evolving.
Always changing, always moving.
And there are always new and exciting things to discover.
For those of you eager to dive deeper into TSQL.APP,
yeah, check it out.
You can find a wealth of information and documentation on their official website, TSQL.APP.
TSQL.APP.
Go forth and explore.
Until next time.
Until next time.
Keep diving deep.
Keep diving deep.
Keep questioning.
Keep questioning.
Keep pushing the boundaries of what's possible.
I like it. Push those boundaries.
See you in the next deep dive.
Yeah.